What are quadratic functions? Well, the word quadratic means when the largest exponent is 2. So a quadratic term is something like 3x squared. The quadratic expression is 3x squared minus 48. A quadratic equation is like an expression, but it has an equal sign, so we see 3x squared equals 48 is a quadratic equation. And a quadratic function has a second variable in it, so f of x or y equals 3x squared minus 48. Um, the times that we will see quadratics most often are area, because when you have some sort of area, it's usually something like x times x plus 3, and then we'll see, okay, this is x squared plus 3x. That's an area of, that is quadratic. Gravity is also quadratic, um, and profit is sometimes quadratic, not always, but specifically if you're talking about a price going up, if the price going up causes the number of sales to go down, then as you increase the price, the sales go down, but you're still multiplying those two things together. So these are both linear functions. Price is a linear function, sales is a linear function. If they're both linear, then multiplying them together gives you a quadratic. These are the most common quadratics, but it is possible to have quadratics from other things. Um, in recognizing quadratics, in an equation, you'll see something like x squared, that highest exponent of 2. In a table, the second difference will be the same. So an example of that is if you have, let's say, 1, 3, 1, then the next one would have to be, this went up by 2, this went down by 2, so overall it went down by 4. So going down by 4 again, meaning our next difference would have to be 6, bringing 1 down to negative 5. And then we would go down by 10, so then it'd be negative 15. So our second differences are all going to be the same. That it's not that the values changed by the same amount every time. 1, 3, 1, negative 5, negative 15. It's going up a little, and then going down a little, and then going down more, and then going down more. But the second differences are the same. And in a graph, you'll see this type of curve, one of these two, and this is called a parabola. So on the previous parabola, that's what the shape is. So on the previous slide, you saw Angry Birds and flight paths of falling objects count as parabolae, which are quadratics. The singular of parabola is parabola. The plural is parabolae, although many people will use parabolas. All right, so simple example. You see y equals x squared. This is the simplest function, the parent function. Y equals x squared, so that makes it quadratic. You see this is going down by 1, then up by 1, then up by 3, then up by 5. So the second difference is going from negative 1 to 1 is adding 2, then adding 2, then adding 2, because these are all the same. That's how we know it's quadratic. And if we plot these points, they're already plotted here. We can connect these. If we continued, it would actually look like this, making something like a U shape. And that U shape is called, once again, a parabola. Here's a different parabola. So negative 2 times x minus 1 squared plus 7. 0, 5 is here. Then 1, 7, 2, 5, 3, negative 1, and 4, negative 11. So here is part of that parabola. We could continue on the other side as well. Parabolas are symmetrical, and we will definitely be talking about the different pieces of a parabola. The pieces of a parabola are the x-intercepts, where y equals 0. The y-intercepts, where x equals 0. The axis of symmetry is the line that splits it into the two symmetrical pieces. The vertex is that point at the top, which is either the maximum or if it's a point at the bottom, it's still the vertex, but then it would be called a minimum. And then the domain is almost always going to be all real numbers. And the range is going to be based on the y-coordinate going down or based on the y-coordinate going up. There are also two other things called the focus and directrix, which are ignored in most Algebra 1 classes, but you'll see them in Algebra 2 or pre-calculus, and these are a visual, but I'm not going to go into them now. One last thing, there are 3 different ways of writing quadratic functions. The main way, the one that you'll see the most often, is standard form. Y equals ax squared plus bx plus c, so a, b, and c just in order. This is a normal polynomial. You can turn standard form into root form, where it's factored by factoring. And you can turn root form back into standard form by simplifying. You can also take vertex form, a times x minus h squared plus k, which has the vertex listed, and get back to standard form by simplifying. To go from standard form to vertex form is more complicated. Usually the method that we do is complete the square, and that is something we'll learn for the first time in this unit. Thank you.